So nice big problems to waking you back from spring break. We're going to look right here at the secant, and if you look at your notes you will see that the secant of theta, this is theta here in parentheses, will equal the same thing as 1 over cosine of that angle. I'll use theta instead of saying negative pi over 3. Just think about that first of all. So when we find the secant, we're really going to find the cosine and then put it under 1. Or another way of saying that is if we get a fraction, we'll just flip it. If we got 5 over 1, we'd now say it was 1 over 5. That's the first thing. And then the second thing is SOHCAHTOA. If you think about SOHCAHTOA, we have SOHCAHTOA. That's SOHCAHTOA. And we're going to be using cosine, so we're thinking about the ka part. So CAH is saying that the cosine of this angle, theta, is equal to the adjacent over the hypotenuse. Okay, so we're going to use that. But of course we have to think about something else, and that is if you have your coordinate plane here, and you go in a negative direction because this is negative, and if you were going to go that way, I guess I don't want to leave that on there, but if that's the negative direction, this is negative, and if you're going positive, that's the positive, but this is negative, so let me get rid of those. I don't want them in the way. But if you went all the way over here to pi, that's the same thing as 180 degrees. That's half a circle. Well, we're not even going that far, because if we went to pi, it'd be, negative pi. We'd swing the arm down and around till we got halfway around the circle and stop at pi. But this is pi divided by 3, which is the same thing as 180 divided by 3, since pi and 180 are the same thing. And if we divide 180 by 3, we get 60. So honestly, we're just going to swing down 60 degrees, okay? So that's just our way of saying swing in a negative direction, okay? And go 60 degrees. So we did, and then we dropped down this line at a 90-degree angle, which means that this over here has to be 30. And I'm really hoping that in your mind now you're thinking, oh, I have this reference triangle in my notes somewhere, and it goes like this: 60 degrees and 30 degrees, and of course I have my 90 degrees. And in your notes it's going to have a hypotenuse of 2 and a base of 1, and the height is the square root of 3. And you say, well, let me label these sides up here on the triangle the same way. You say, okay, well, 30, you can see that 30 opens up on 1, so this 30 should also open up on 1. And this 60 opens up on square root of 3, so this 60 should also open up on the square root of 3. And the right triangle opens up on 2. The 90 degree opens up on the hypotenuse of 2. Alright, so we said that we were going to use the cosine of theta of this angle. Turns out theta is 60 degrees. Easier to say 60 than negative pi over 3, right? And so we're going to say the cosine of that 60 is the adjacent. Well, what's adjacent to 60? Well, the cosine of negative 60 is equal to 1. That's the adjacent side. The adjacent side is 1, and the hypotenuse, we're supposed to be over the hypotenuse, is 2. So if, by the way, that's a positive 1, so I don't have to worry about the signs. If I was using this square root of 3, that would be a negative, but I didn't have to use it, so I don't have a negative here. The secant is that upside down, so that means that the secant of our negative 60 degrees, or I could say negative pi over 3, or if I went positive, I could say it's, if I went all the way around positive, that would be 300 degrees, wouldn't it? I could say positive 300, but I'm not. I'm just going to say the secant of negative 60 is equal to 2 over 1, or just 2. So this big intimidating thing here that we just did, that's just 2 right there, okay? So 2 plus what? Well, let's see. The cotangent, and I hope that you think about the cotangent as being 1 over the tangent of theta. If you look at your notes, you'll see that cotangent is related to 1 over tangent. So we're going to find the tangent of this angle, and then we're just going to flip it like we did the 1/2 down here. We flipped it and became 2 over 1. Because we like dealing with cosine. We like dealing with tangent. We don't so much care about secant or cotangent. Alright, so now let's think about our angle. And you know that if we go 360 degrees around in a circle, we really haven't gone anywhere. We're back to our starting point. And that's the same thing as going 2 pi. Half a circle is pi, and the whole circle is 2 pi. So if you think about the fact that if you say 12 pi over 6, that's the same thing as 2 pi, right? 12 divided by 6 is 2. So we've gone more, in the negative direction, we've gone more than one circle around. We've gone all the way around plus a little bit more. So we really don't care about the 12 over 6 part. We care about that one last part to make it to 13. So really we're thinking about the cotangent of negative just 1 or just pi. I'm not going to write the 1, I'm just going to write pi over 6, because 12 of those pi's out of 6 is really 2 pi, and that's nice. We went around in a circle, but we didn't really go anywhere. And then we kept going. We kept going to negative pi over 6. So let's go ahead and draw that. And let's see, pi over 6. If pi is 180 degrees and we're dividing it by 6, and we're going, you know, in that negative direction again, we keep going negative here. Pi is 180 divided by 6, that's 30. So I didn't go quite as far this time. I only went down 30 this time. So that means that's 60, and here's our 90. So we have the same reference triangle, it's just laying differently down here. So it's very important that we think about, you know, how we assign these sides. And we said that 60 is supposed to open up on the square root of 3. So 60 opens up on the square root of 3 over here in our picture. And 30, we said 30 opens up on 1, so 30 is opening up on 1 here. And again, the right angle is opening up on 2. Our hypotenuse is 2. And honestly, you know, we're thinking about the tangent, and then we're going to flip it upside down I could write negative pi over 6, but I'm going to write negative 30 degrees, because that's the same thing. And when I do that, SOHCAHTOA, remember I wrote SOHCAHTOA up there? Should I use a different color to highlight it? This time I'm going to use this TOA part up here, TOA, okay? And that says, tangent of theta is equal to the opposite over the adjacent. We always are talking about what's over what. So TOA means tangent equals the opposite over the adjacent. So what is the opposite over the adjacent? Well, let's see. The opposite of 30 is 1. So I'm going to say 1 over the adjacent. What's the adjacent? Well, it's the square root of 3. And here our negatives are going to get us, because this is under 1, so that's negative 1. This is under the x-axis, I mean. There's the x-axis up here, the x-axis going like this. And this is clearly below it, so that's negative. This is positive on the x-axis, so that part's positive, but that 1 is negative, so I don't have a positive anymore. Remember that I said when I find the cotangent of this, I'm going to just flip it upside down. So let me do that. The cotangent of negative 30 is equal to negative square root of 3 over 1, or just the square root of 3. It's a negative square root of 3. So when I add these two things together, remember my first answer was here, 2. I get 2 plus, well, I shouldn't really write the plus. It's going to be negative, so I'm going to say negative square root of 3. Yeah, they're both over 1. I don't really care. I don't need common denominators. I don't need denominators if they're both 1. And I'm pretty content with having a radical in my answer as long as they're not in the denominator. So I have 2 minus the square root of 3, and that's it, the end. That's what I was looking for.